Okay, so we are continuing with the adding and subtracting rational expressions. This time, this is what it looks like with unlike denominators. So honestly, the concept still applies. So I'll use examples that we know and that we've done before, and then we'll just apply them to polynomial expressions. So first of all, the property is stated as if you have a divided by c and you add or subtract b divided by d. Now you see here that we don't have our denominators are not the same. And so we have to have a common denominator. And so the common denominator here has to be composed of factors of c and d. So the left only has a factor of c and the right only has a factor of d. And so the concept here is that you want to manipulate the way that this looks. So here, I can multiply this by d. But the thing is, in order to keep the value of the fraction the same, I have to multiply the top by d as well, because d divided by d is equal to 1, and 1 times by a divided by c is equal to a divided by c. So we're not actually changing the value by multiplying by d divided by c. And so, but I have to do the same thing on this right side as well if I want a common denominator, except I want to make sure that this has a factor of c, so I multiply this by c, but again I have to multiply the numerator by c as well. So I'm multiplying it again by c divided by c, which is equal to 1, because anything divided by itself is 1. So therefore, I'm not changing the value of this rational expression because I'm only multiplying it by 1. And multiplying something by 1, also it doesn't change, is the same thing as itself. So when I do this, this comes out to be a times by d on the numerator, and on the denominator, d times by c. And then plus or minus, and then I have b times by c on the numerator here, over d times by c on the denominator. So you see that we now have a common denominator, so I can add the numerators at this point. So AD plus BC over D times by C. And this is, of course, when C and D does not equal 0. Okay, so what you could always do in a situation where you have unlike denominators is multiply the numerator by the denominator on your second ratio, and then multiply the numerator on the right side by the denominator on the bottom left. And by doing this, you get common denominators. But you don't always have to do this, okay? So an example of where something like this would be useful is say that you have 2 divided by 5 plus 1 divided by 3 as an example. So to get a common denominator, well, I can multiply this side by 3 divided by 3 and this side by 5 divided by 5. So 3 times by 2 divided by, so 3 times by 5 would be 15. And then plus, and then this side I want to multiply by 5 divided by 5, which would be 1 times by 5, which is 5, over 3 times by 5, which is 15. So you see how we created a common denominator there. And then this is equal to 6 plus 5, and then over 15, and that's equal to 11 over 15. So you see, in this case, I could just multiply this side by whatever this is right here, and then this side right here by whatever this is right here. Okay, now in another example though, let's say I have something like 1 over 9, and then I want to add 2 over 3. Now, you could do the same thing. I could multiply both sides by 9, okay? So I'll do this in 2 different ways. So I'll do it the way where how this definition states to do it. So if I multiply this by 9 over 9 and this side by 3 over 3, I get 3 times by 1, which is 3 over 27, and then plus 18 over 27, which is equal to 21 over 27. Okay, now if you can reduce, do so, but I'm not sure if 21 and 27, actually they do have a common denominator. They have a common denominator of 3, or not a common denominator, but a common factor, because 21 is divisible by 3, so that would be 7, and 27 is divisible by 3, that would be 9. So you see here how we got this answer and we had to simplify. Now look at what I do here. If I go back to what I had, so if I have 1 divided by 9, so this is method 1, I guess you could say, and this is using definition. Now this is going to be method 2. This is using the least common multiple. Okay, so I'll show you what that means. So 1 over 9 plus 2 over 3. Okay, so a least common multiple is a concept that, so if we take the denominators here, 9 and 3, and list out their multiples. So multiples of 9 would be 9. 9 times 2 would be 18, times by 3 would be 27, so on and so forth. And 3 has multiples of 3, and then 6, and then 9, and then it would have 12, 15, 18, so on and so forth. Okay, now the least common multiple, so it's pretty much just in the name. So common multiple, so look at here, these have common multiples of 18, of 9 and 18, eventually you'd have 27 as well. But the least common multiple is the one that appears first for both of them. So you see here 9 and 9 is the least common multiple of these. So what that means is that I don't have to multiply this side by 3 to get a common denominator and this side by 9. All I have to do, or this side by 9, I just have to multiply this one by 3 and multiply this side by 3, because then I get the least common multiplier of both sides. So I get 1 over 9 plus 6 over 9, and that would be equal to 7 over 9. So you see here that I didn't need to go through this step right here of simplifying, because I multiplied just one side by the least common multiple. So if you can multiply by the least common multiple, to get the least common multiple, try and do that instead of doing it by the definitional way, because this adds a step of simplification, because you're going to have to simplify further down. And so that's what this says right here. Now I'm not going to go through any of these examples, because I think it would just be better if I showed you rather than finding the least common multiple. I will show you exactly how it's actually applicable, like in these examples. So, and again, I'm going to do this in the next video.